Now for these last two examples, we're going to put it all together. I want to be able to convert from one form into its alternative form. I might need to use a calculator for it, I might not, but that's what we're going to do. So in this first example here, we first need to identify what form it's written in. You can clearly see that I have an r as well as a theta, so I'm going to be converting from polar into rectangular in this example. So I'm going to have to use the calculator to do that. The reason why is because 205 is not a known angle that I'm used to on the unit circle. Doesn't mean it doesn't exist, but it means I have to use the calculator to find out what the cosine or sine of 205 is. So we're going to get our calculators and we're going to find out the values of the cosine 205 and sine of 205. Remember also that since I'm dealing in degrees here, I want to make sure that my calculator is also in degrees as well. So let's just take the cosine of 205. Oops, 205. We can see that that's going to be negative 0.9063. And let's take sine of 205 as well. And we'll see where we can go from here. You can see that that value is negative 0.4226. So what I've got so far is 7 times, I take cosine of 205 on my calculator and I find out that that's 0.9063. I'm going to add that to the sine of 205, which is negative 0.4226. I. Don't forget the I because this is the imaginary part here. Now I just multiply each of these two numbers by the 7, which for us is R on the outside, and you can see that this is going to be negative 6.3441 plus the imaginary portion, which is, whoops, minus, we'll call it a minus, 2.9583I. So this is the real portion, this is the imaginary portion, and that's what we would consider a rectangular form of this complex number. Now the second example over here is going to go in the opposite direction. For this one we are starting in its rectangular form and we're going to move into its polar form. So I have to find what r and theta are in this particular case. So that's where we had our 4-step process from above. So the first thing I want to do is I want to draw my picture. I know that I am moving negative 7, so I'm going to move in to the left over here, and I'm moving up 2. So I have a vector, or I have this representation right here. So I went negative 7 in the x direction, positive 2 in the y direction, and what I need to find are theta as well as r. So r is going to be the square root of the x value, negative 7 squared, plus the y value, which is 2 squared. In other words, r would be equal to 49 plus 4, which is just the square root of 53. Can't simplify that any further. And then theta is the inverse tangent of the y value 2 over the x value negative 7. So on my calculator I'm going to have to do this again. So we will pull that up and we will take inverse tangent of negative 2/7, negative 2/7, and you can see that I get a value of negative 15.94. Now hold on before we put that value down. When I take the inverse tangent on my calculator, it should return a value for tangent in which quadrant? Think about that for just a second. So what happened? It returned for me, in other words, it being the calculator, it returned this angle right here, which is negative 15 point something or other, 0.95. So it gave me this value here, yet I want this value up here. That's a difference of, let's see, that's a difference of 180 degrees. So if I were to take what my calculator gave me as negative 15.95 and add 180 degrees to it, I would be back up here, which is where I need to be. When I do that, I find out that theta is equal to 164.05 degrees. So I have r and I have theta, and I can write this polar form as square root of 53 CIS 164.05 degrees. And that's the solution for going from a rectangular into a polar form of our numbers.